So
So that's right.
6 times the square root of 800. We want to simplify that down. The 6 we can leave alone for a couple of seconds. We'll just tackle the rad 800. Alright, I need two numbers that multiply to 800, one of which is the largest possible perfect square factor of 800. 402. Now, if you went like 108, you wouldn't be out of the game completely because you can still salvage it from there. But you want to be looking for the best possible perfect square. All right, square root of 400 is? 20. So we have 20 root 2. So then we have to bring down the 6. Now, it's a relationship that we'll talk more about as we go forward, but you can't multiply rational numbers by irrational numbers. So if you have a 6, you can't multiply it by the radical 2. You can't add it to the radical. You can't do anything. The only types of numbers that you can multiply between would be rational numbers, like 6 and a 20 can get multiplied, or if you wanted to multiply two radicals, you could do that also. All right, but you can't intermix between the two. All right, so basically, long story short, it's telling me that I'm going to get 120 times the square root of 2. All right, the big concern comes from the idea of, okay, well, how do I know 400? If you don't know your perfect squares, you need a resource. That resource could be your calculator. Go into your y equals menu, and you just type in x squared. When you type in x squared, if you go to the table, it's going to square every value in your x column. So every value in your y column would be a perfect square. Every value in the x column would be the square root of that number. All right, so I could just go down the list, but you still have to do some thinking at some point because you do need to know which ones go into 800. Now, you can get fancy with this if you want and do a little 800 over x to come up with the factors of 800. But this could get pretty messy. So you start looking at the factors of 800. So the first column and the third column. And again, if you don't have the kind of number sense that helps you get through this without using a calculator, you need this approach. The first column and the third column would give you the factors of 800, because 1 times 800 is 800, 2 times 400 is 800, and so on. Ignore the fractions because we're trying to avoid those. All right? But then what you would do is you cross-reference. You would say, okay, 800, is that a perfect square? I don't know. Let me go in my perfect square list, which is y1, and see. Is 800 in that list? Keep scrolling. No, 800 is not a perfect square. So that would not be a good choice. 1 in 800 would not be a good selection. So then I would try 2 and 400. Maybe you don't know that 400 is a perfect square. But in my y1 column, if I see a 400 there, I would know it's a perfect square. And there it is. All right, so that's your indicator that 2 and 400 would be the way to go. Now, you don't have to do the two functions simultaneously. Ideally, you would only have to use one of the functions, either the x squared or the 800 over x, not both, because you should be able to consider it and go down your list. In fact, if I get rid of my 800 over x, just pretend that never happened, and just look at my list of perfect squares, at some point you should be able to go through it and say, all right, 800 divided by 1, useful? No. All right, 800 divided by 4, right? That's 204, maybe. Is there something that beats that? 200 divided by, or 800 divided by 9, no. 16, no. 25, maybe. Could there be something better? 36, 49, blah, blah, blah. 100, that's even better than the ones we had before. Is there something even better? Keep going. 400. Once you get to the halfway point of whatever your number is, so you're scrolling along, once you get to the halfway point, if you haven't found the best number by then you're not going to find the best number. But if you've already found the best number, that is it. right? So the halfway point is your last stop. Because anything larger than the halfway point is going to create a fraction if you divide it in, right? So just words of wisdom. I mean, I've been doing this long enough to know what people struggle with. And aside from simple things like, you give a person, I mean, I've seen, here's a common mistake, I see this all the time. The question will say, simplify. And it'll be the square root of 16. This is what I see. So far so good, right? But then inexplicably, somebody will do that and call this their final answer. No, that's not right. Right? It's a single operation. The square root of 16 is equal to 4. The square root of 16 is not equal to 2, but sometimes people just can't stop themselves from finding square roots. So that's a common error that I see. Okay? So if you look at that and thought, oh, that's ridiculous, like who would ever think to do that? Like a good 40% of the population has done that at some point, so lots of people. If you were to think to yourself, oh yeah, I probably would have done that myself, then I'm talking to you, I guess. The other thing is really coming from the little tree diagram that we're creating here. So what happens, we talked about this yesterday. I'll just actually do it here. What happens if you go down the wrong path? It's not over. You had the square root of 800. Let's say you thought it was the square root of 100 times the square root of 8. All right, that's fine. You got a 10. You can't just stop and say, okay, I did it, it's done, because you know 10 radical 8 is going to be one of the choices, and it's not going to be correct. If you're one of those folks that goes into a test and says, or actually comes out of a test being like, I totally rocked that test, but then you get your test back and it's like a 60, and you don't know why. Turned out you got nailed on the multiple choice. You're probably falling into the little traps that happen on the multiple choice, right? So consider your factors and think, can I go further with this? It's a matter of discipline, which is not always the easiest thing to teach. All right, so when you break that down further, you get 2 radical 2. So now I have a 10, a 2, and a radical 2. So I would have the 20 radical 2, and then when I multiply that later by the 6, I would get the 120 radical 2 that we were looking for. All right, so very important. You can't rush through this process. This makes a big difference down the line. Now, one skill that can be useful is the idea that they say that you shouldn't have a radical in the bottom of a fraction. I'm still struggling on why that's necessarily the case. So this is called rationalizing. The denominator. I think the skill of being able to move a radical from one part of a fraction to another is important, but I mean, when I went through the system, like you are now, I was led to believe that you were breaking some sort of rule, some sort of law that would put you in jail if you had a radical in the bottom of a fraction. You look at all these problems, you've got radicals in the bottom of a fraction all over the place, right? So we want to simplify. First off, if you have a radical over a fraction, that means the radical applies to each part of the fraction. So we're looking at the square root of 25 over the square root of 7. What is the square root of 25? 5. Square root of 7 is some decimal that we don't know, right? All right, now our plan here is to not have a radical in the bottom of the fraction. All right? Now, we're learning about rationalizing the denominator, but you could also rationalize the numerator depending on what you're looking for. So if you don't want a radical on top, you could follow a particular technique. If you don't want a radical on the bottom, you can follow the technique I'm about to show you. right? And that is to multiply the top and bottom by a single number. That number would be what? Are we going home early?
Yeah, we are.
Yeah, baby!
Let's go!
It's 1 o'clock, but still. Let's go. Oh boy. I've never felt so alive. I think I'm going to start crying. It's so great. Oh, it's so great. I could tell from the little reactions throughout the room that something was going down.
That got punched. I thought there was someone that got you. I'm so happy.
Oh.
I was like, why is my text like the psychopath? Are you
It's so hype.
Yeah. I'm so
This is my last class of the day.
Take it in. My mom was like, you're getting so long. Wait, this is like my good day.
So great.
Oh my god.
I think so. I don't think they're going to shorten schedules now. I think it's just going to be like whatever period you're in at that time that's the end of it. All right, so the skill here is really the only thing you have to do is multiply top and bottom by whatever the radical is in the bottom of the fraction. All right. So 5 radical 7 on top. If you multiply across. Now, what is radical 7 times radical 7?
Is it like nothing?
I heard a lot of things that I would not classify as technically correct. Radical 7 to the second, which is the same as radical 49, which is the same as
Radical 7. No.
7.
Oh, I did my dialectical journal last night. I should have done that. I did my
So this is the same as saying radical 49. That radical 49 is a 7. All right. So the radical that remains in the top of the fraction can stay put. It's already in simplest form. 7's a prime number. You can't break it down any further. The 5 and the 7, neither of those are radicals. They can't be simplified further because 5 doesn't go evenly into 7. So that would be our final answer. All right. The second example, we just have to clean it up a little bit. Before you break up your radical into 2 separate radicals, you may want to consider simplifying what's on the inside there. 5 over 15 simplifies down to what? 1/3. 1/3 under a radical. All right? So then that's the same as the square root of 1 over the square root of 3. Which is the same as, well, what's the square root of 1? 1. Square root of 3 is the square root of 3. Oh, that's a poor quality thing there. All right, so now I have a 1 over radical 3. If I'm telling you that you need to rationalize the denominator, I have to multiply the top and bottom of this fraction by what? Radical 3. So 1 times radical 3 on top is radical 3. On the bottom, radical 3 times radical 3 is 3. Because it'll give you radical 9. The square root of 9 is 3.
So when you always multiply the two radicals at the bottom, is it just the bottom?
Yep.
I tried to screen mirror something and it said I can't do it because someone else is using it. I guess it's like a new Apple TV thing.
Oh, the one at a time?
Yeah, it doesn't let me. I was gonna screen record and then like do a voice that said "Yeah, baby," because and it's gonna work out.
Just stop.
Well, I mean, if you want to get creative, you can just download the YouTube video I post later. Throw it in there. Yeah, I mean, it's all going to be in there. I didn't hit pause, so. I have to put something in the description that, like, the freak out going on has to do with the fact that we have an early dismissal. I mean, it's the perfect storm. I mean, it's like a bright sunny day, check, 2-hour delay, and an early dismissal. We ran the trifecta. I mean, like, it's the perfect.
The title, teacher goes ham, not clickbait.
Featuring some math. All right. Last problem for today. This one, it's already broken up. I can't simplify a 3 into 2. I can't simplify a 5 into 2. What do you think my first move ought to be? Hint, I drew a multiplication symbol.
Multiply both by negative, or 2 radicals. By negative.
By this thing.
Wait, why not 2 radicals?
Well, because if you, well, I can't even speak. If your goal is to get rid of the radical, then the 2 is fine on the outside. It's the radical that needs to go. So ignore the 2 and just multiply it by the radical 2. All right, so on the top, we'd have 3 times the square root of what?
Radical 10.
Radical 10, so 3 rad 10. And then on the bottom, we have the 2 that was already there multiplied by rad 2 times rad 2, which is 2.
Rad 4. What?
So 3 rad 10 over just a 4.